Lesson 1.3, Task 3. Reflections of function graphs. For the parameters in function rules that indicate stretches or compressions, a negative value indicates that there is also a reflection across the x or y axis. Each graph below shows a function f in blue and a function g in red formed by reflecting the graphs of f across an axis. To the left of each graph is a mapping diagram of the input and outputs for f and g corresponding to the graph. Alright, so you can see for this one it says g of x equals negative f of x. Okay, so the inputs are the same and the outputs g equals negative f. So each of these values times negative 1 equals this. So you can see what this does when we do have negative f of x. This point goes to here, this point goes to here, this point goes to here, and this point goes to here. So it is a reflection across this x-axis here. Okay? Alright, now g of x equals f times negative x, and that's in parentheses again. So that's going to change my input value, because remember my input is my x value. Alright, so I have 1 times negative 1 equals negative 1. So these are different. And then in this case my outputs are the same. So f times negative 1 equals g. Alright, and you can see in this case, this point goes to here, this point goes to here, this point goes to here, and this point goes to here. So this time it reflects across the y-axis. Again, this is negative f of x. Remember, f of x is your y value, so it reflects across the x. And here, this is f of negative x, so it's changing the x, or the input value. So this changes the output, this changes the input, just like the other task. Alright, so compare the mapping diagram of the graphs of f and g in the top row. Which statement best describes how the inputs and outputs of f and g compare? So the inputs are the same, and g is opposite f. Alright, so each input for g is the opposite, each inputs are the same, and for a given input, the outputs are opposite. So that is true. And then it says, what effect does the parameter of negative 1 in the rule g of x equals negative f of x have on the graph? Okay, again, it's a reflection across the x-axis. And it says, compare the mapping diagram and graphs of f and g in the bottom row of the table. Which statement best describes how the input and outputs are the same? So again, remember the second one is changing the input. Alright, so this one changes the input and the outputs are the same. Alright, so it says each input of g is the opposite of the corresponding input of f. And for a given input, the outputs are opposite. Each input of g is the opposite of the corresponding input for f, and the outputs are the same. Okay, so the outputs are the same. Alright, so what effects does the parameter of negative 1 in the rule g of x equals f of negative x have on the graph of f? So when it's inside, it reflects across the y-axis. So that's the middle one here. And it says in part A, the negative sign reflects the graph vertically, while in part B, the negative sign reflects the graph horizontally. How does moving the negative sign from outside to inside the function result in this difference? So very much like the other stuff, if you input a value into a function, obtain an output, and then multiply it by negative 1, gives the opposite of the original y value, which indicates a vertical reflection across the y-axis. If for the same output value you must find the opposite of an input of G to obtain the input of F, it means that the X values are opposite for these output values, which indicates a horizontal reflection, which is across the y-axis. Okay? All right, so it says for an even function, f of negative x equals f of x for all x in the domain of f. The graph of an even function and its reflection across the y-axis are identical. All right, so you can think of an even function like y equals x squared. That's the graph of a parabola. And the reflection, if it's like the parent function, is going to have a vertex at 0, 0, that is going to be a reflection on top of itself. All right, for an odd function, f of negative x equals negative f of x for all x in the domain of f. The graph of an odd function is the same when it is reflected across the y-axis as it is when it's reflected across the x. All right, so it says, is the function f graphed above even, odd, or neither? All right, so this would be neither, because if you these are reflections, but it's not across this y-axis here. Okay, so this one is a reflection across the y-axis, and this one is a reflection across the x-axis, but these are not considered even or odd functions. Let's see what this has to say. All right, neither. F is not even because the graph of f is not identical to its reflection across the y-axis. F is not odd because the reflection of its graph across the y-axis is not the same as the reflection of its graph across the x-axis. Okay, again, that is a mathematical definition for that, but just be aware that those are not even or odd. All right, if you have any questions, please let me know. Lesson 1.3, Task 4. Graph a combined transformation. A function rule may combine the transformation parameters you have seen in this lesson. The table below summarizes the effects of the parameter on a general function f of x. All right, so you can see this is kind of important. This is your general formula here, and it shows you that if A is in front of f here, if A is positive, it's a vertical stretch. If A is between 0 and 1, it's a vertical compression. If A is negative, when A is positive, if it's opposite, it's negative A, but it's only when A is greater than 0, is a reflection across the x-axis. And B, when B is positive, it's a horizontal stretch. When B is between 0 and 1, a horizontal compression. The opposite of B, or when B is negative, as long as B is greater than 0, is a reflection across the y. H, when H is greater than 0, or when H is positive, it moves you to the right. When H is negative, it moves you to the left. When K is positive, it moves you up. When K is negative, it moves you down. All right, so these are things that you should definitely have in your notes. And then it says, describe how to transform the graph of f of x shown to obtain the graph of g of x equals negative f times 2 times x minus 3 minus 1, and show the graph. All right, so they're showing you that A is negative, and this is, it should be 1 over B, so this is 2, so it would actually be 1/2, because it's 1 over B. And then it's minus h and plus k. So this is 3, and then this one's negative 1. Okay? All right, so match the parameters of g of x when negative f times 2 of x minus 3 all minus 1 to their effects. So A, negative 1, is going to be a reflection across the x-axis. B is a half. That's your horizontal compression by a factor of 1/2. H is 3, so that's going to move you right 3 units. K is -1, so it's going to move you down 1 unit. Okay, so these, again, A, B, H, and K are just pulled here from the equation. All right, why is the value of B equal to 1/2 and not 2? Because if you do 1/2, as the formula states above, that's how you get the 1/2. So you can see right here it's 1/B, and so that would just be 1/2, which turns it into 1/2. All right, why is H positive and K negative? Again, it just depends on whether it's affecting the X value or the Y value, your input or your output, and that's what makes the difference there. All right, apply these transformations to a few reference points on the graph. Remember, B and H affect the graph's input, and A and K affect its outputs. For a point X and Y on the graph of f of X, the image of the graph of G of X is Bx plus H, comma, AY plus K, and that equals 1/2 X plus 3, or -Y minus 1. Okay, so let's take this right here. It's going to equal this right here. So let's say -2 would be our X, -1 would be our Y. So let's just plug that in. So if I do half of -2, half of -2 is -1. -1 plus 3 is 2. So if I look down here, it's going to be 2, 0. And I can check my Y value by plugging -1 in. -1 is plus 1. 1 minus 1 is 0. So that works out. All right, let's see what our next point is. Let's take 0 and plug it in. Half of 0 is 0. 0 plus 3 is 3. So our next point should be this. And then I can plug in -2.2 minus 1 would be -3.2. So that works. All right, so the last one is going to be half of 3, which is just 1.5. 1.5 plus 3 is 4.5. And then we can check the Y value as well. Take 3, plug it in. So it'd be -3 minus 1 is -4. So those reference points should be correct. Okay, so all we did was take this right here and substitute our X and our Y value in to find those points. All right, does the horizontal compression change all the reference points? All right, no, it does not change the reference points, 0, 2.2, since the compression multiplied X by 1/2, and half of 0 is just 0. Anything times 0 is just 0, so when you multiply by 0, it's not going to change anything. All right, so it says, look at the graph. Okay, so remember above the original graph was this blue line here, this blue curve. And when we applied all the transformations that they gave us, this would be the new image. Okay, all right, so that is all for task 4. If you have any questions, please let me know.